Hey, it's Mr. Allred, and we've been working with exponential functions. We just did interest functions, so these are the compound periodic interest functions. Just to remind you what that looks like, we have the function a of t equals p, our starting amount, times a big old parentheses of 1 plus r over n, all that raised to the n times t. That was the formula we've been using in the lecture videos. So the first question we have here is a bank offers a 5% interest rate compounded quarterly. How much does a $4,500 investment increase to after 10 years? Excuse me. So let's put everything down. What we know is that the starting amount is $4,500. The R here is 5%, but we'll change that to a decimal, 0.05. N is the number of periods per year, which quarterly means 4. And the T here is how many years? So that's 10. So we have everything on the right-hand side to plug in. So let's see here. We're going to have A of T, well, A of 10, since that's T, equals $4,500 times big old parentheses of 1 plus 0.05 over 4, all raised to the power of 4 times 10. And my instructional videos show you how to put this in the calculator. So let's take a moment to do that. 4,500 times. Alright, so we should get something bigger than 4,500, and I do. If you don't get the same thing I do, reach out, or please go back and watch the instructional videos if you're missing those. $7,396.29, since we're talking about money. Pennies are where I would round. So that's the answer. So another one, I'm just going to go ahead and write down the formula here. A of t equals p times 1 plus r over n raised to the n times t. So the question is, you borrow $5,000 for a car. The loan costs an interest rate of 3.5% compounded monthly for 3 years. How much will you end up paying back in total? Okay. So identify the parts. P, the starting amount that you're going to borrow, is $5,000. R, the interest rate is 3.5%. We move that decimal 2 places, 0.035. The N, number of periods per year, it says monthly, so that will be 12. And T is the number of years, so that is 3. So plug all that in. We got A of 3 for the number of years equals 5,000 times 1 plus 0.035 over 12, all raised to the 12 times 3. So I'm going to put that in my calculator, and let's see what we get. Alright, so I've got, not as impressive as the last one, $5,552.70. Okay, so that is the amount the account would be worth after 3 years, compounded monthly. Thank you.